Warning: scientists have discovered new proof that a parallel universe exists. The piece of evidence? An elementary particle called the tau neutrino, which is observed behaving very strangely. An experiment in the Antarctic region captured the unusual behavior of these ghost particles, which revealed the possible existence of a parallel universe. What are these ghost particles, and why do they prove that multiple realities exist? In today's video, we'll explain in detail what these ghost particles are and how they prove that parallel worlds truly exist. The intriguing concept of parallel worlds. Parallel worlds, infinite realities, multiple universes. They come by multiple names, but share one compelling concept. We are not alone. You are not the only version of yourself that exists, and there are universes beyond ours. One of the pioneers of this theory is Hugh Everett, who also proposed the many worlds theory, which basically implies that every action you make creates a new universe based on that decision. With Everett's hypothesis, the idea of parallel worlds inspired many people. Since then, every single piece of evidence that our scientists could dig up has been examined to prove that a universe beyond our own exists. And recently, scientists have found the evidence we are looking for. In our last video about parallel worlds, we talked about the concept of neutrinos that were observed in the Antarctic that seem to be moving backwards in time. But what exactly are these neutrinos, and how did they prove that parallel universes exist? So, what exactly is this ghost particle that could shatter standard physics? Before we look at the evidence scientists uncovered, we must understand the most essential piece of the evidence: the mysterious ghost particle, the neutrino. Neutrinos, in fact, are everywhere. Just at this exact moment, trillions of neutrinos are passing through you, and you'll never notice. You cannot see them or feel them. These neutrinos, which some regard as the ghost particle, almost never interact with any matter. Neutrinos are elementary particles, meaning that they cannot be subdivided into other particles the way atoms can. Elementary particles are the tiniest known building blocks of everything in the universe, and the neutrinos are one of the smallest of them, 1,000,000 times less massive than an electron. Neutrinos belong to the lepton family, which is a class of subatomic particles that does not undergo strong interactions. Lepton has 3 classifications depending on mass: electron, muon, and tau, and all of them produce a neutrino, with tau neutrinos being the heaviest and because of that are most likely to be observed. Neutrinos are exceedingly abundant. In fact, one physicist suggested that our own sun is emitting trillions of neutrinos every second, bombarding it in every direction as the hydrogen fuses into helium in its core. All of these neutrinos will be blasted into the vast universe, and because they barely interact with anything, neutrinos move through space in a straight path for millions or perhaps billions of years. In fact, neutrinos do not only form in stars. They sometimes are even produced inside your own body from the radioactive decay of potassium, which is used for maintaining normal levels of fluid inside our cells. But the highest energy neutrinos are born far out in space, in environments we know little about, maybe in supermassive black holes or huge supernovas, at places where fusions and breaking down of atoms are prevalent. These extreme entities in space accelerate cosmic rays to energies almost 1,000,000 times greater than anything human-built accelerators have attained. These cosmic rays, primarily protons, interact violently with the matter and radiation around them, producing high-energy neutrinos. And lately, in an experiment for catching high-energy tau neutrinos, scientists noticed something that has never been seen before. They observed neutrinos travel back in time. But if these neutrinos scarcely interact with any matter, how did we even catch these neutrinos? ANITA, the world's largest neutrino detector. One thing about neutrinos is that they are incredibly hard to detect, even if trillions of them are traveling through space. Neutrinos are very good messengers. They retain important information about the star where they originated from, which we may utilize to grasp the actual nature of mysterious space phenomena like black holes and what truly happens in a supernova. That is why scientists designed a radio telescope that is meant to catch these valuable neutrinos. This is the Antarctic Impulse Transient Antenna, or ANITA. This instrument detects ultra-high energy neutrinos by exploiting the so-called apeiron effect. This effect looks for radio emissions that are created during high-energy particle collisions. In other words, ANITA is detecting a snap of radio frequencies induced by the high-energy neutrinos. In order to detect these radio emissions or apeiron pulses, we need a radio-transparent medium for the interaction to occur in because these interactions are so uncommon. Materials that are radio-transparent include salt, sand, and ice. Scientists utilize the ice in the vast Antarctic region as a particularly radio-quiet region to detect neutrinos through weak apeiron pulses. Going to the Antarctic region, they are putting a huge volume of pure radio-transparent material in the path of neutrinos, which is 1 cubic kilometer of ice that has been purified by the pressure of thousands of years of accumulated ice and snow. In that sense, this ice has become one of the purest solids on Earth. Inside this material, when a neutrino collides with a molecule of ice, it will shoot out sparks of subatomic particles, and then it will hit some of the detectors positioned over a mile beneath the surface. Then, a photomultiplier tube, which is an extremely sensitive detector of light, amplifies the signal, which is then transmitted to astrophysicists throughout the world. With this powerful neutrino detector, scientists have been accumulating several anomalies, but not like this one, as they spotted a neutrino that is traveling backwards through time. How these detected neutrinos prove that there is a parallel universe. Remember earlier when I mentioned that neutrinos usually move through matter? I said mostly because the ultra-high energy neutrinos do sometimes interact with matter. That is why we can catch some of them using ANITA. But recently, ANITA has detected something unusual. While probing for showers of neutrinos coming from space, ANITA detected a shower of tau neutrinos coming from inside the Earth. Could those just be neutrinos that have already gone through the Earth? Well, no. There is so much matter inside our Earth that high-energy neutrinos will certainly collide with this matter and will not survive a journey through the entire planet. The current hypothesis scientists suggest is that these neutrinos are traveling backwards in time. There is one more plausible possibility though. This tau neutrino has an interesting feature in that it regenerates. These neutrinos have short lifespans, but when they decay at high energies, they produce another tau neutrino. If this decay happens in the atmosphere or inside the Earth, it will create a cascade of particles like a cosmic ray, thereby blasting neutrinos coming from Earth. But scientists were skeptical about this idea because, even with the regenerations, it could not penetrate that far through the Earth and produce a shower of tau neutrinos. It would bump into various matter here on Earth and will eventually run out of gas. The only idea that explains this anomaly is that these neutrinos are moving backwards in time, in another universe besides ours. Why can we say that they are indeed moving backwards in time? Because it is the only plausible explanation for why these neutrinos are coming from the direction of the Earth. It means that these neutrinos are moving backwards. So how does this prove that there is indeed a parallel universe? Remember when I said that we are just three-dimensional beings? We cannot navigate through time. We cannot go into the future and to the past. The universe as we perceive it is in 3 dimensions, which means that if the tau neutrinos are indeed moving backwards, those tau neutrinos were not from this universe and must be coming from another universe where time is running backwards. A bizarre universe where everything goes back in time. Though scientists find the hypothesis far-fetched, this is the only explanation we have.